I think this is one of the a little more straightforward lessons that you have. The idea of translations, I always think of them as like pushes, right? When we translate something, all we're doing is sliding it in a specific direction, right? So when I push something, say I was going to push a chair, I just need to know what direction to push it in and how far, right? So those are the two things you have to know to be able to do a translation, is what direction are you going in and how far. And so people in geometry have created this thing called the vector. The vector doesn't have a location. So it is such an unusual geometric object. This is called a vector right here. Okay? I'm going to try to zoom in a little bit more on this vector thing. So you can see that it's written, kind of hard to see here, but it's written as a P. Then it has like an arrow on it, but the arrow only goes back one way, as opposed to like when we make array, when we make like a letter for array, we do an arrow with going back both sides, right? So that's array, ray R, we would say, and this would be where we just go back one way. That would be like vector P, okay? And so the thing about the vectors, it says two things. The first thing it says this is the direction that you're going to go in. And the second thing it says is this is the distance. The word mathematicians use, they call it a magnitude. They say it has a magnitude. And that's helpful for a lot of physics problems. It's talking about the magnitude of a vector. And in some higher level math stuff. But for us, for a translation, it's just really answers the question, what direction are we going to push the thing and what distance are we going to push it? So here we have, if you look here, this is this right here is a trapezoid, right? MLMNO. And what we're going to do is we're going to use vector P to translate it. And you can see like vector P has been created here with dotted lines. And so it tells us exactly how far, and all we have to do is put the dots here. M, L, so we have L prime, M prime, N prime, and O prime, right? If you connect them, you have your new translated, oops, probably should do a better job connecting them than I'm doing right here. You have your new translated trapezoid. So pretty straightforward. It's already been done for us, right? Here we go. It says, use the figure and the given translation vector. Draw the translation of the figure along the translation vector. So here we have triangle VUT and vector Q. Vector Q goes this direction, this distance. So all I have to do is show where V prime, U prime, T prime is, and connect them, and I'm completing the translation. Okay? This one's kind of interesting because they're showing the back end of the translation. So they're showing where S, let's see, this is where S prime ends up. This must be P prime over here. Here we have R prime and Q prime. So where were the original points? Well, they would have had to be where these dotted lines ended up. So we'd have something like this. There's S, R, Q, and P. And if we connect them, we get the original quadrilateral and the translated quadrilateral. Okay, and here we have a pentagon. So A becomes A prime, B becomes B prime, C becomes C prime, D becomes D prime, E becomes E prime, and all we're doing is just connecting them. So when I say it's one of the simpler ones, mathematically, this is not asking us yet to do a lot of the work. We're just connecting points and drawing lines, right? Now as we move forward, it gets a little more complicated because now we're going to have to plot the original points, and then they give us this. Now notice this 2, 5 is the coordinates of the vector. It is not in a parentheses, but it's in these kind of brackets right here, right? And so this is telling us still the change in x and the change in y. So this is saying go to the right 2, or x over 2 positive, and y up 5, right? So we go up 5, so this is telling us wherever we make this object, we're going to push it to the right 2 and up 5. That's the coordinates of the vector. So now we'll just go ahead and plot each of these points. So J would be at -4, 1, 2, 3, 4, -4, 1, 2, 3, 4. So there's point J. Then we have K at -1, 2, -1. That's K. And then we have L at +2, -4. Right? So this would be L. So this was our original triangle here. And then remember, we're going to the right 1, 2, and up 5. 1, 2, 3, 4, 5. So that's the vector here. I'm going to draw it just the way they did with a little dotted line. This one goes to the right 2 and up 5. 1, 2, 3, 4, 5. And there's our vector there. The last one goes to the right 2 and up 1, 2, 3, 4, 5. So there's vector there. So this point becomes J prime, K prime, and L prime. And you can just connect them. And that is literally all there is to it. Plotting your points, understanding this new concept of the vector. Okay. I won't do this last one, but you can see this vector says go to the right 4 and up 4 because it's positive. Oh, sorry, this one is, I was looking at points, the coordinates for point L. The vector coordinates say go to the left 4 and down 3. That's what this vector coordinates mean. Left 4, down 3. Okay. One other thing I think I'll show you real quick, what it looks like when you do these both on a calculator. So let me make a calculator document here. I'm going to add in the graphs page. So if I were doing number 6, this can be kind of helpful. I would plot all my points. So I'd go down here where it says geometry. I would do points and lines, select point on a graph page. Then I could just start opening my parentheses and putting in these coordinates. So I have 4, 2 right there. I have 4, -1 right there. I have 0, -1 right there. I have 1, 4 there. And lastly, I had 4, -1. 4, no, let's see. Oh, it's just a quadrilateral. So let me get rid of that point. Four, 2, LMNP P, right? 4, 2, 4, negative 1, 0, negative 1, and 1, 4. Sorry, let me get 1, 4 back again. So again, that's open parentheses 1, enter 4, enter. So there's my 4 points. Then I would get my tool that makes my polygons in geometry under shapes and find your polygon tool and just connect these 4 together. Kind of looks like a kite a little, but I don't think it is. No, I really don't think it is. Not a kite. Okay. Next thing is look under if you go into geometry and you go under, here it says points and lines, you can see that we have a vector tool right there. Number 9 is the vector tool. And if you hover over it, it says click 2 endpoints or press open parentheses, then coordinates for the vector. So here we go. We're going to start at 0, 0, and we're going to go to the coordinates they're given is negative 4, negative 3. And that created my vector, which is right here. And now I can move my vector around. You can see I'm really not changing the vector. I'm changing its location, but that doesn't change the vector. I'm going to set it off to the side here. It still is the same distance, the same direction. So when I translate it, here I'm going to go to Geometry, Transformation, Translation. I select the polygon. I select the vector. I get my new coordinates. Okay? The only last thing I might want to do is know the coordinates. So under Actions, Coordinates and Equations, I can now click and find out, well, what happened to 1, 4? It became negative 3, 1. And what happened here to this point? Became negative 4, negative 4. This point became something, I don't know what that is. That's a bad number, negative 4. I wonder if there's something funny about that. I don't know what it is. And this one became 0, negative 1. Let's see, what number should this have been? We were going to the left 4 and down 3 from here, so it should be 0. I don't know why this one's showing 0 and this one's showing not a 0. Should have been 0, and then it would have been, let's see, down 3 from negative 1, so it should be 0, negative 4. That'd be the coordinate, 0, negative 4. Yeah. Yeah, and this number is such a small, minor amount off, but I don't know why that is. Maybe I messed with this point here, the vector somehow. But anyway, you should always be able to like trace your object with your vector and see that every point lines up with that vector. How I'm doing here. You can do this also on Geogebra. So if you go to Geogebra, I like the classic view of Geogebra, but you just place your points in as well. This is really helpful if you get an assignment that you have to do. So you're working at home, you know, needing to get your assignment done. If you learn how to use Geogebra, it'll help you. Maybe someday you're in college and you're going, yeah, I wish I had some of those tools. Geogebra is a great free tool. Yeah, Classic, I like that version, but there's a lot of different ones that are okay. Now down here I have Vector. There's my Vector tool. And I'm going to enter vector. I'm going to show you actually, you don't even need your vector tool. I'm going to enter it down here. And the key with the vector is, you notice these points all have capital letters. If I want to put the coordinates in for a vector, I'm going to call it vector V. I just put lowercase v equals, then put those coordinates in, -4, comma, -3, and it created vector v right here for me. And you see, this is the other more common notation for a vector, where the x value is on top and the y value is on the bottom. But different publishers have different ways of denoting a vector. Either way, now that I've got this, oh boy, this vector you can't move like that. Moving it will redefine it. So we'll just do our transformation. That's under here. It is a translate by vector. I select the polygon, I select the vector, and I get my new polygon, complete with all of the coordinates here listed for us. So here is A prime, B prime, C prime, and D prime. Really handy, okay? Really handy little deal. All right, guys, that is it for today. As you look on your side, you're going to have just a handful of these that you need to do. So go ahead and get them done. Okay, if you need help, we're happy to help you.